I'm gonna have to. There we go. I'm gonna have to poke Don and have him make us a theme song for the show. Welcome everybody to another episode of our Labs Open Office Hour. This week we're joined by Kelly Shipman. I think our new, or not any longer our newest Labs member, because now we have Devin behind the scenes. So the audience I don't think we'll ever get the chance to meet Devin, but
no, we keep him in.
But as I've just learned today, you've taken on, I knew this was coming, but it was just recently happened. You've taken on a little bit more. You're now taking over all of the rendering, all of the cool 3D stuff.
Yep.
It's not just
3D stuff.
Yeah, which is super exciting because, and kind of makes sense. They do seem to kind of play together, right? Yeah. So, I guess right off the bat, I'm just curious for my own sake. How does that change anything, if at all?
It gives me more to do. On my side, that's the biggest thing.
Yeah.
For Puget in general, it's going to allow William to kind of tackle some additional stuff, not specific software stuff, but he's going to look more hardware-based reviews and stuff. They're going to be really interesting. Like he did an article not too long ago about like comparing different chipsets or comparing like PCI, X16 versus X8 when you're on Gen 4 versus Gen 3 and that kind of more granular stuff. That's going to be pretty interesting.
Yeah, I'm excited.
So as a whole, it's going to add a lot more to Puget.
Yeah, that'll be cool. Right on. And so lately, the latest things I've been noticing that we've been testing is the A6000, the successor to the RTX, because they dropped the Quadro name.
They dropped Quadro.
And so this is this like the next generation then?
Yeah. So it's basically the Quadro RTX 6000/8000 successor. That's what is replacing those two.
Okay.
And I say those two because they're the same GPU, just different RAM amounts. There's the only difference between those two cards. And the A6000 has 48 gigs of RAM. Is that right?
That's huge.
Like totally forgotten what what it has. I just remember it was a lot. A6000. I don't remember. Yeah. I think it was 48. And that's what the RTX 8000 had was 48. And the RTX 6000 was 24.
Okay. Wow. Wow. Big steps up. And that does make a big difference for, I know for like some large jobs in things like V-Ray and Cinema 4D, I think, things like that, right? Yeah. So that's
all the 3D packages, you have to be able to store your entire scene, everything you're rendering into VRAM.
Wow.
They can like push that over into regular RAM, but then it like has a huge performance impact.
Oh snap! Okay,
because then it has to then like be fed back through the CPU and traveling back and forth, and it's not great. So if you can store the whole thing in if VRAM, it's better. Some programs will just if you exceed VRAM, it just won't work.
Oh, so wow. All right.
A lot of Unreal stuff will just crash.
How can you I imagine there must be some way of knowing ahead of time, right? Yeah.
Well, you can just open up the system monitor on your computer and see what VRAM is being used. And it's basically the more stuff you put into the scene, the more VRAM. It's a combination of textures, number of them, how big they are, the 3D models, how dense the geometry is on them, makes the memory increase, because basically you have to think about how many vertex are in each piece of geometry, and there's each piece of geometry or each vertex has 3 coordinates plus the color information and stuff, and then you got millions of them. Like it adds up quickly.
Sure.
So all that kind of stuff.
That's cool. So and so actually I think today's going to be a little exciting for those of in the audience who follow these sorts of topics, because you were just telling me before the stream you have all the data, but we haven't published the articles yet. So this very exciting for the folks at home, because you guys are you're going to see it here first on the spot while it's hot. So let's just jump into it, man. Let's see what are we doing? What do we got?
Sure.
What do we got here? I'll
so
share this.
Start off with Unreal,
of course.
Because this is the main thing that I focus on is Unreal. It's the benchmark that we're currently developing, trying to figure out all the nuances that we want to test and all that kind of stuff. So for right now, this is just focusing primarily on 4K performance, how basically how the frames per second you can get
during while you're manipulating it, while you're
well, that, and while you, like, if you were to hit the play button and you start playing a scene or whatever, what you can maintain. So this is 4K rasterized, meaning not using any ray tracing effects. So just the old school way of doing it for real time.
Yeah.
And you can see massive improvement for the A6000. We're looking at what, 86% faster than the RTX 6000.
Yeah.
And for like a couple $100 more.
That's amazing.
So yeah, this is nice. It's huge. It's basically the same performance improvement we saw with 2080 Ti to 3080. It's like that kind of generational gap. So it makes sense that we see this kind of increase, because it's basically the same thing. It's just the professional hardware instead of the consumer hardware.
Yeah. All right.
So yeah, that was that's right. I'm under control of the this part. So yeah, we're not terribly surprised with that. Oh, this is a weird screen capture. Oh, whatever. It worked better when I had a second monitor, because then I could just do the screen instead of the window. But
sure.
Whoa, whoops, went too far. So here we go. Ray tracing. Ray tracing starts to have a lot bigger impact on the hardware. It's not just looking at the raw performance of the CUDA cores. It's looking at the ray tracing cores and all the other stuff that's going on.
Yeah.
So we're still seeing a 60% improvement. It's still like a good improvement for, just a little bit more money than the RTX 6000. I should step back a little bit. For Unreal, very few people on Unreal will want this A6000 or any Quadro card. You're looking at people that need Quadro, or whatever this is now that's no longer Quadro,
right?
Because they dropped it for some reason. They need that card for stuff other than its raw performance.
Okay.
Its raw performance is kind of a secondary thing. For Unreal, you're looking at architecture people who need Quadro for their other software programs, for the CAD, for all that other simulation stuff that they're doing.
Yeah.
And they just want to be able to render something in Unreal. So they want to make sure they're still getting good performance. Or virtual production people who need to use a Quadro sync card to be able to sync their LED wall with their camera and the renderer. So everything is lined up. So like there's a lot of people in virtual production who were still buying the RTX 6000 even after the new 3080s and 3090s came out, because they need that feature. Like without that, it's pointless.
Right.
Well, you can get by, but it's a lot more difficult because you can't synchronize the rendering with the wall and the camera, and it gets messy.
Yeah.
So for those people, they can now finally get the A6000 and see the generational improvement that we saw on the consumer line.
Yeah.
So that's going to be huge.
Before we move on, I'm curious, so say I'm I'm into this. What differences is this going to make for me, like on the day to day?
So, like, if you're a virtual production person, per se,
Yeah,
what this means realistically is that you can now push more stuff to your scene at any given time and still maintain your frame rate.
okay,
In virtual production, especially if you need the quadro to sync everything together, you're not exceeding 30 FPS anyways,
sure.
because that's all your camera's going to capture. That's probably all your wall can refresh at anyways. You're not going to exceed that, but that just means you can do that much more on screen at a time and still maintain that frames per second.
So like, I in my mind, and as the I suppose the audience, the kind of average Joe here, I always think of the Mandalorian in these contexts. So they'd be able to do more complicated backgrounds. Like there could be like a mega battle or something going on, and not just a flat landscape.
Basically, yeah.
Oh, that's super cool. Okay,
you can just do more stuff back there. It's been pretty cool to watch what these people are doing in developing all this stuff. I was watching some guy that's working on real time, like lightsaber effects. That is pretty crazy to me because on the LED wall, you're talking about stuff that's just being displayed on a wall behind you.
Right.
Which is great for stuff that's in the background. But if you're holding something and then that's now like in between the actor and the camera, it's not, you can't see the wall. It's not being rendered on the wall. So it has to be rendered in XR. But then if you move that thing behind you, now it's being occluded by your body and has to like not render it because it's being hidden. And like, how do they figure that out? So people are figuring out these crazy things. That's the biggest limitation to the big LED walls is effects that happen in front of the actor or in between the actor and where the wall is. If there's other geometry.
That seems like a big deal.
Yeah.
Like, so what I'm understanding is that it's almost real time, like motion capture. Like if I'm wearing a green morph suit, they could wrap me around with a costume and it would, that's so cool.
Yeah.
Wow. That's a big deal. I think that's huge.
Yeah. So they have to develop all that kind of stuff. And having this much more power means you can start to consider doing some of those effects in
like real
time. Yeah. I mean, they're probably using separate computers for that anyways.
Okay.
In a virtual production, if you're doing a giant LED wall scenario, there's probably like half dozen at least computers all working together to do different things. So there's probably like the computer that's running the background, running the LED wall, and the computer that's running the foreground effects. And then they're being comped together real time somewhere down the line.
Wow.
Yeah. So yeah, the A6000 will just let people do more stuff and still be able to maintain their visual
man
they want.
I can see at some point it'll almost all be fake or digital, like you almost won't have to do practical effects at all.
Yeah. I mean, they always say like that, but if you compare practical effects to visual effects, there's just something different about them.
Yeah.
I mean, that'd be a great conversation to have with like the corridor guys.
Oh, sure.
To have them talk about the choices to make in that space. A lot of people in the virtual production world see these LED walls as like the end of green screen.
Okay.
And like, I don't know if that's going to be the case or not. I'm not as in the world as they are, so maybe they see more.
Sure.
But I just see there's so much other stuff where things need to be comped together. Things have to be rendered after the fact. But you can definitely do so much. It's so cool.
Oh, right on. All right. What else we got?
So then let's go to offline rendering. So not real-time rendering, but the traditional rendering that you would do. So I'm still kind of learning these software packages. I only started these this week. So This is Redshift. This is showing how long it took to render this scene. So you see the Quadro RTX 6000 took 255 seconds, whereas the A6000 took 174 seconds.
Wow.
So that's a big chunk of time saved per frame. Well, I don't know how many frames this is. I need to look into the details of that. But yeah, it's not a long render. So,
I mean, you're saving what, a little over, or what, just about around a minute for this render. I mean, those add up.
Yeah.
It's no joke.
And yeah, I don't know if it's just a frame or if it's a few frames, but whatever it is, it's not very long. It's just long enough for us to get a result. So I would probably guess it's a single frame, just from my experience with these renderers. So yeah, Redshift, you can see a huge improvement to go to the A6000 if you need a Quadro style card. The offline renderers might do Quadro for if you have big server farm, if you do a render farm, or we're currently looking, don't know for sure if we can get 4 of these into a system or not. Currently, we can't do that with the 3080 or 3090 because it takes too much power. This, the A6000 only takes 300 watts, I think. I can't remember. Whereas the other ones are 325 or 350. And we can't get them to work, 4 of them in a system. Right. But this might be able to.
Ooh, that'll be nice.
Yeah.
And especially because the Quadro line traditionally are almost always blowers, right? They don't do the funny fan setups and stuff, which goes a long way to stacking them into a machine.
Yeah. This one is a blower, like fan opening on both sides of the card. Yeah, like on top and bottom. So I'll be curious to see when we do stack them what that does. Like, are they going to be fighting each other for air or what? It's a so Redshift looks really good. Octane Bench, the really popular renderer. This is a Octane Bench. They have a benchmark built into their renderer. Yeah, and it gives you a score. So that's what we're looking at here is the score. So anyone can go download this, run Octane Bench, and then see what their score is and compare it to these. So yeah, the A6000 is like 80% faster. It's a significant bump in speed for this.
That's great.
And then we see the same thing. What was that?
Oh, so I've heard Octane a lot in visual effects and stuff, like with the corridor and stuff. That's how they do. Well, I think that's their main one for their visual effects, if I recall correctly. But it seems to be pretty popular in that space.
It's very popular for that space. They moved to V-Ray. V-Ray is used a lot in VFX, but also it seems to be very popular among like architecture, some of those other industries. Yeah. V-Ray has 2 different scores that it gives that we can run. There's a CUDA score, so only using the CUDA core is not using ray tracing at all. And there's a ray tracing score. So the CUDA score, we're approaching double the speed.
That's amazing.
Yeah. Which I find personally, so all of these renderers we're using, the benchmarks that are built into the software.
Oh, okay.
Unreal is a benchmark that I've been developing myself. So this makes me feel good because this is about the same performance increase that we saw in Unreal. So I was like, okay, good, I'm doing it right.
Oh, hey, yeah, that's great.
I saw 80% faster in rasterized, which is what this would be. Okay. Well, kind of, but not using the ray tracing cores anyways. Yeah. So yeah, we're seeing 80-90% speed increase. Yeah. Which is like, it's unbelievable. And then ray tracing, we are just shy of double.
Yeah.
Wow. Yeah. So huge increases. This one I actually have to run again because the the Quadro RTX 4000 scored higher than the RTX 5000.
I was gonna comment
to,
on that. I wonder what that's about.
Yeah, I need. So all of these, and even the CUDA score was close to the same. All of these we run 2 passes on. When I was compiling the results, for some reason the 4000 only had 1 pass, so I just need to run it again to see if maybe something happened or what's going on.
Mm-hmm.
But yeah, it should be. I mean, they're pretty close anyways. Yeah. So yeah, the new A6000 finally out. I think they said it was out, like launched in December or something like that. But we're finally able to get our hands on one, or 2.
Oh,
yeah. We're trying to get more,
and that's why there's a shortage, of course.
Yeah,
because
we got our 2. We're trying to get 2 more so we can do 4 in the system, see if that can work.
Yeah.
I think Don wants us to get 8 so we can try and load up a server, but I don't know about that.
Of course he does.
I'm like, Don, these are like $5,000 each. Like, come on, Cole. Expensive to test.
Yeah.
Yeah. So the RTX A6000, I'm always gonna be calling it Quadro. I don't know I'm gonna break myself of calling it Quadro.
Yeah, right.
Definitely huge improvement. It'll be great for anyone doing any kind of 3D work, whether it's real time or offline rendering. If you're using a Quadro and you need to stay on the professional grade, then these are gonna be huge upgrade for you guys.
Yeah, that's great. Once they're available.
Yeah, you just have to keep checking. People always ask me this in the communities I take part in. Mm-hmm. We don't use the standard because we're a system integrator. We don't go to like eBay, not eBay. We don't go to eBay, but we don't go to like Newegg, Amazon. Those are like last ditch. We have system integrator vendors.
We get to go another step up.
Right. Although sometimes a lot of like the graphics cards actually are going to Newegg first. I don't know. I can't explain it. I don't know what the hell's going on anymore.
I can kind of see why they would do that. Frankly, they just, at least from NVIDIA's angle, they probably are just more interested in appeasing the general consumer. They know they have a guaranteed sale from a system integrator. We're going to be buying them no matter what. They need to get as many of them into the hands of the general public as possible.
Yeah. So the A6000s are out there. You just have to see if you can find them. But yeah, they're great cards now.
Yeah. Right on. Was that it, Ben?
That's it for like the benchmarking results.
Okay. All right.
But yeah, if we want to talk any other game dev, 3D work, whatever, you want to ask questions?
Sure. Well, just some goofy stuff about our beards and things so far. Yeah. I'm a little curious, just because you've kind of got your fingers into these spaces a little bit, obviously more than I do. Is not just from a raw performance point, but do you find that either companies or individuals try to stay on the bleeding edge like this? Like, are they clamoring to try and get the best of the best always, or?
That ranges from place to place. Okay. So in the virtual production world, for example, they are bleeding edge all the time, but the entire pipeline that they use is bleeding edge. Like, they are making things up as they're going. They're constantly trying new trackers to like track where things are in the actual volume, the camera, the actors, all that kind of stuff. Mm-hmm. Like everything, it's all like, there's not really like you go to a place and buy a setup to do virtual production. Okay. Everyone's still homebrewing it, putting it together, that kind of stuff. We're starting to see a lot more professional grade stuff coming out, but yeah, that entire industry is bleeding edge. in game dev, a lot of the game dev is less bleeding edge
Okay.
because it's not the performance of the developer that matters. It's the performance of the consumer.
Right.
So if you buy a 3090 and you're getting 30 frames per second as you're developing the game and you're maintaining that, who is going to buy your game that can maintain that performance? You know, like, so a lot of times they're like a step behind in what they're developing.
Okay.
Some of the bigger studios still want the newest card because they're developing now for a game that will be released in 3 years.
Okay.
So they were anticipating what a system would be like that far into the advance. So they want to make sure their systems work good now.
Yeah.
And then other people like architecture, those people, it's about the stability of the system. They just want things to work. So they're not looking at raw performance necessarily. They're looking at some other factors.
Okay.
It kind of varies from person to person.
Sure. I'm kind of let's see. I remember my short contract with ILM. They were here's just a comment, I suppose, from Leviathan Prime on Twitch. I remember my short contract with ILM. They were constantly changing out computers, not so much that it did something faster, but that it allowed them to create something they were previously unable to.
Mm-hmm. Yeah. That's something in the VFX world that's kind of somewhat unique to them, is that it's not necessarily that like I can render this scene faster, because they can throw more like hardware at the rendering pipeline to get it done faster if they need to. It's about allowing the artist to do more with their time. That's something that the guys at Corridor have talked about in the past, that with the systems that we've built for them, is not necessarily that they can do like more of their films in a year. It's like they can make them look that much better. So yeah, they will look for bleeding edge for that reason. So they can just do more. They can make it look better.
I've noticed that in other spaces too, where like it's all well and good that I can render faster, but nobody's actually, nobody's just going to stay in place, right? I'm not going to do the same things I did 2 years ago quicker. I'm just going to take that same hour and do something bigger, better, prettier. Which is, it's kind of cool, but at the same time, I would kind of want to take advantage of having work done faster,
Right.
So,
and to a similar degree on the game dev side, like when I was a developer, the performance of your computer is not necessarily like all the computers we're using. We're developing for Xbox at the time, Xbox 360 specifically. All of our computers were way faster than the Xbox was, and it wasn't because like what our target was. It was because it made sure that the computer wasn't getting in our way.
Yeah.
If we need to model out something that's millions and millions of triangles, and then we're going to then bake it down to a smaller thing, and bake all the normal maps and all that kind of stuff, we want to make sure that the computer could handle that high res thing that the target computer, the Xbox, is not going to need to do. So yeah, it's making sure that artists can do their thing and kind of get the computer out of the way, which is what Puget likes to do. We want the computer to get out of your way.
That's right. This is a little off topic, I suppose, but it's very interesting to me, the terminology. Like I wonder where you say bake, you bake the lighting or the normal maps and stuff, and it's like there's not an oven. This isn't a loaf of bread. Like I wonder where some of these terms come from.
Yeah, that's one I just kind of was told, and I was like, okay, cool, that's what it's called. Yeah, I don't know because like the baking it, that's not like a button in the system. Like you set it up and you like render, you click the render button and it renders out your map, your normal maps. It doesn't say bake anything. So
yeah, it's just, I bet it has something to do with like probably old animation or like pottery somehow. I bet.
Yeah.
You know.
Yeah, pottery might be good.
Yeah, that was just funny. Oh yeah, Philippe NW on YouTube, he comments, yeah, it saves you from having to optimize the first version of an idea before you can test it. Just throw raw muscle at it.
Yep.
Yeah, that's cool. I like that. Man, I'm curious too about I just lost it. I'm sorry. I had well, I'm what do you find most interesting about the industries that you look into?
So my primary software package for the past year has been Unreal. And just looking at that in itself, one of the most interesting things I found about that is how many different industries are using Unreal. Like it started off as a game engine. That makes sense. And then some like filmmakers started adopting game engines to be able to do like pre-visualization, because you can get stuff in fast and kind of get it moving, get a look going.
Yeah.
Then it started being used with like, you'd see people like with an iPad or some kind of mobile screen that they're like the director's like moving around in a space to kind of like block out shots and stuff like that in 3D space, but they're not going to use it for the final thing. They're just like trying to it's a way to visualize everything.
Okay.
And kind of started with that. And it's like, well, now the visual quality looks really good. We can do like a TV series out of this because TV series usually have a lower quality render to them.
Sure.
Because they're working on time constraints. They're trying to pump out so much every year.
Right.
So they have a little bit lower, and they're like, well, this is the same quality we were doing there, so let's use this. And then started going to movies, and then it's branched out into engineers are collaborating in it because you can have multiple users working on a scene at one time. They can be working in VR and looking at the actual have a car that they're developing, and they have the actual car sitting there. They're talking to each other in VR. They can measure things out. And they get a feel of what they're doing. And then from that, automakers have now adopted Unreal, and it's going to be running the UI for the new Hummer electric vehicle. GMC announced that their Unreal Engine is powering the dash entertainment system thing. It's just,
that'll be cool.
It just keeps going and going, and all these different things are using it, and it's crazy to watch.
I did just recently see the next generation of Tesla. You could play The Witcher 3 on it.
Yeah.
And I mean, I don't know that that's really a feature I care about in a car, but it's interesting, I suppose.
Yeah. I mean, it sounds crazy, but you also remember The Witcher 3 is available on the Switch. Right. So it's not like you need a lot of power. So it sounds cool, but then maybe not that impressive. I don't know.
Yeah, I don't know. It just seems
got to see gimmicky. Are they what settings are they using? Are they using ultra? Are they?
Yeah, I don't know. That's going to be a major selling point, but it's cool to know, I suppose. Oh yeah, Leviathan Prime comments. I've used game engines to model out what something might look like for company X. It's been a lot of fun.
Yeah, game engines just by their nature are just very fast to work in, especially to get just something to see.
Yeah.
Because you don't have to render anything, and then you can if you're doing just basic models, basic textures, not doing a whole lot, you can have it running at a playable frame rate just really quickly. But if you were to do that in a traditional, even in Max or Maya, you need to render it out, and then it takes longer and all that kind of stuff. So yeah, the game engine has been great for just iterating things. Yeah. That's why they're used for pre-visualization for so long.
That makes sense. Yeah. Kind of in a similar way that animatics for 2D, right? You just kind of sketch out these weird kind of almost flipbook style, it's real janky, but you kind of get the idea. Oh, a little Unrelated but interesting. It doesn't. Philippe asks, "Don't Tesla models have a ton of GPU muscle for autopilot?"
I'm not sure.
I'm not 100%, but I would think that the car itself doesn't. They would use a lot of GPU power to build the model, like the neural model for the autopilot, but not real time. You're
Yeah, I
not
don't.
There's not 8 GPUs in your Tesla real time crunching that data.
Right. Yeah, I don't know what they have in their in the hardware, but also you have to remember, especially if it's a custom chip
Mhm.
that a lot of them will use, doesn't mean you can port a software package like a game to it easily, or that game will be able to run smoothly on it, even if it has a lot of teraflop performance.
Right.
It might not work great for a game engine. So it's starts getting into apples and oranges at some point. So I'm not sure what a Tesla has in it for raw power, but it's surprisingly a lot.
I imagine, yeah. I mean, wow. How has the Unreal benchmark been going for you?
It's been going good. It's kind of a lot of times I feel like I take a step forward, 2 steps back type thing.
Mhm.
I need to start doing my blog posts again about kind of documenting some of the stuff, even though I'm having some setbacks.
Mhm.
But I realized when I started testing the what was it, the AMD 6900 XT, that kind of illuminated some problems I had somewhat seen before.
Yeah.
But then I finally, with the 6900, like figured out what the problems were and what the limitations were I was experiencing, and need to kind of redo some stuff. Around the same time, Unreal had a new update come out that added new features. So like they have a new GPU light mask baking. Before it was all light, were all baked via the CPU. Now it can be GPU. Has just crazy.
That's going to be helpful, right?
Yeah, it's fast and it looks way better. So like it's not just that it runs on the GPU, it's a whole new like framework underneath that's giving better results.
Cool.
So I need to go back and develop that. So there was one scene in particular that I was using as a benchmark that was architectural visualization scene that the FPS in 4K is like 2 frames per second.
Yeesh.
And when I was running the 6900, because 6900 doesn't do great in ray tracing,
Right.
it kept hitting 2.5 FPS for no matter what resolution I was running it at. And like, this is weird. And then anything below 3080, all the previous generation NVIDIA was also hitting 2.5. I'm like, this is weird, because like it's the software is set to run 3 minutes, count how many frames are done in those 3 minutes, and then give me a FPS. Yeah. It's a pretty simple math.
Sure.
So I was digging into it and realized that how it was tracking the seconds was based off of when a frame was rendered. It would wait a second. So like if there was more than a second between a frame, it wouldn't count a second until the next frame started. So if it took 2 seconds to render a frame and then a thing started, it would be like, oh, it's only been a second. And so all the math was off, but somehow it always ends up at 2.5 frames per second.
That's weird.
So yeah, I had to dump that scene altogether. But I'm going to transition that scene into a rasterized scene with the new GPU light baker, because that's what I'm seeing a lot of virtual or art viz people doing, is just doing a light baked into the scene, because they don't need time of day changes. They don't have lights moving. They just like are panning around, like whatever building they're doing. Yeah. So they're using that because they can get better frames per second, still look really good. So I'll use that for rasterized, and then figure out how to time the GPU light baking using that scene. Because right now it doesn't, like when you hit start, it doesn't tell you when it's done. It's kind of over. And so I'm trying to figure out how to get some calls in there and that kind of stuff. So yeah, there's been some like setbacks in the thing. Some other stuff that I've found new ways to do. So instead of running it in the engine, I've actually been able to create a standalone executable for a level that I could essentially send to anyone.
Yeah.
They run it, and it'll produce a text file that has your FPS for whatever resolution you were using.
That's cool.
So yeah, that is a good step forward. I have in the works a way to set the resolution before it runs, so I can have it like force it to run in a window that's 1080p, and then force it to run in a window that's 4K and report different results. So it needs some automation to be done outside of Unreal that will then launch these things in that resolution and report everything. And
wow.
So that could be really good. But again, that will only give me performance, only FPS. I can't do that for importing models. I can't do that for compiling code and that kind of stuff. That has to be done in the editor. So still need a way to automate the editor.
Okay.
But yeah, so there's been some nice improvements. There's been some setbacks, and it just keeps going. It's the way it is.
Yeah.
Anyone that does software work out there knows what I'm talking about.
Yeah. I've not to go off on a tangent, but when I was doing software, I remember distinctly working on a project. I've run it just before going to bed or whatever. Like I'm done for the day. I run it, make sure it does what I expect it to do. Save, go to bed, wake up the next day. Nothing has changed. Literally nothing. I opened the project, tried to run it again, make sure everything was like it was. It broke.
Yep.
So, yeah, I feel you on some of that for sure. I feel like I've asked this one before, but how do you decide what to test? I always feel like so much of development or creative pursuits and stuff is so subjective. Like people always talk like, oh, what if I use this brush in Photoshop? Like, or these sliders are janky. Like, what informs your decision to test certain things?
So I spend a lot of time going into various online communities, either Facebook groups, different forums, whatever, and just kind of seeing what people are talking about or asking them questions like, hey, what are the problems you're facing? What, if you're looking at new hardware, what is it that you're thinking of? Like, well, I need this to be faster or this to be smoother or whatever. So I spent a lot of time in different communities. I've also gotten a lot of feedback on previous articles saying, hey, why don't you add this or whatever. On one of my Unreal articles, someone gave me some good information on like, hey, can you add importing meshes and then also creating an LOD, which is a level of detail, and what was the other one? I think he wanted me to test creating a collision mesh around it. So those are things that like Unreal can do for you, or you can do manually. So yeah, feedback from the community is the main thing of like, hey, this is a problem I have. How can I make it better?
Yeah. So that goes for those folks out there. You out there have an effect on the future of benchmarking. So don't suffer in silence. Right?
Yeah. Just let us know on Twitter or articles or whatever.
Yeah. That's pretty cool. What, I guess on a similar tangent, what are some of you kind of touched on it a second ago, but what are some of your pain points in testing and diving into these sort of things?
For me, figuring out, so it's easy to be like, okay, this task takes a long time, right? let's see, what's a good example? Say if I was gonna like render out a 60-second movie using Unreal's render movie queue that they have.
Okay.
So Unreal doesn't give you a this was completed in X number of time.
Huh.
It's just like started and then it tells you when it's done.
Oh.
And so I have to then figure out a way to like accurately determine when it was started and when it was finished and give me the time without sitting there with a stopwatch. I want to be able to like, the goal is that we can have this all automated so we can be like, okay, run these set of benchmarks overnight and then it'll give us results.
Yeah.
So yeah, trying to figure out how to then capture the start and finish of a thing. For Unreal, I've been able to get some of that done using their own internal scripting. They call blueprints. And they'll find a way to fake some of that stuff. Not all of it can be done that way. That's where I'm struggling with the light mask baking right now, because it doesn't tell me when it's done. It's just well, it says when it's done, but I don't know like what time it finished, what time it started. It does generate a log of everything you do in Unreal.
Okay.
Like it's kind of crazy when you have Unreal open and you're clicking on things. It's reporting a log of pretty much everything that happens into a text file for the entire time you had that open. It's just written out in this weird string of text. And so I'm trying to figure out how to like see where that is, then find the timestamp that's in the middle of the string, not at the beginning of the string or whatever, and be able to pull the information I need to then put it all together.
Yeah.
And it takes a lot of programming specialty that I don't have yet.
Yeah.
Figure it out.
Yeah, that's gotta be kind of cool. What are you you said you mentioned like some of it is built into Unreal. What is outside of Unreal that you're using?
Like Autoit.
Oh, okay.
Yeah, that's the main thing right now. Autoit doesn't like Unreal too much. Autoit doesn't like a lot of programs. So Autoit is based off of basically it needs Windows. Windows has its own ability to like draw a window and display a text button and all that kind of stuff. So if the program is using the Windows calls and all that kind of stuff, Autoit sees that stuff really easily and can be like, as a listener program, you can then like click on a window and it's like, oh yeah, this window is titled this and it has these buttons and it can like read all the buttons and you can say, okay, then I want it to click this button. Unreal, like Autoit doesn't see anything that's happening in Unreal. It can see the window, that there is a window. It doesn't report any of the text that's in the window. It doesn't report any of the buttons that are in the window. So that doesn't work for that.
It's because it's like a Chromium thing or something, right?
Could be. Yeah, I'm not sure what it's based out of. Okay. But yeah, it's not reporting it the way it did when I was doing Max in Maya.
Yeah.
So it's a little bit
weird,
difficult.
Huh.
But right now I'm working on just like getting everything down into a very specified workflow that I can like a document that says, okay, click this button, then click this button, and then your result will show up here. And then do the next test and all that kind of stuff. So that way, if I didn't run it, anyone else could basically open up my document and just go through the steps.
Yeah.
And then potentially someone else in the company, or we contract someone that can like do the programming using C++ or whatever, JavaScript. I don't know what they would want to use. But someone with more knowledge could do something beyond just to auto it.
Yeah. What are some of the more difficult things specifically in an Unreal workflow? Like, I suppose it may be different depending on what you're using Unreal for. So I suppose let's just start with let's say virtual production.
Okay. So what's your question?
Like, what are some of the things that hang up, or what are some of the more difficult tasks in that sort of a workflow?
So actually in virtual production, the biggest hang up people have, the biggest difficulty they have with Unreal is outside of the computer.
Oh,
It's getting your motion trackers, your cameras, all that kind of stuff to then talk to Unreal and like share data correctly and like making everything work together well. That's the most difficult thing that difficult time people are having is just there's so many different trackers out there that you have to get these different plugins to then work with this or use this other software that's running in the background that will then feed data into Unreal and their own plugins for SDI cameras like Blackmagic or I forget there's a couple other companies, but they have, so if you have an SDI capture card, you plug your camera into that and then Unreal can then talk directly with that. But then some of the 3D trackers are a little bit harder. Ironically, the Vive is the like easiest to get working because it's developed for games, so it's supported in the engine and it doesn't have the greatest accuracy. It can be a little jittery, but it'll work and it's easy to get set up. So that's like the go-to for someone that wants to try it out is to get a Vive, because it just like if you have a Vive plugged in and it's all installed and you launch Unreal, it launches the Vive software automatically. It's already there, and then you just have to then use a little blueprints to get the tracker to work. But if you want to use the professional grade tracking systems, those are all different.
Do you think Epic would like fork off a different sort of engine for virtual production specifically?
Maybe. Actually, I don't know. So I said maybe because in the architecture side, there's also, is it Twinmotion? I think it's basically a standalone architecture using Unreal Engine.
Oh, okay.
But I'm pretty sure that was something that they bought from someone else and kind of integrated. And from what I'm seeing, it feels like they're trying to push that all into a one, like try to integrate it back into Unreal and just use Unreal.
Okay.
But it offered some like nice like presets for architecture. You could easier to like switch materials around and all that kind of stuff. On the other hand, Matt Workman is developing a software that will basically be that for virtual production.
Okay.
Now I forgot the name of it. But he's basically creating a software package that's designed for virtual production using Unreal Engine, but it has like shortcuts for setting up cameras and getting all that stuff working.
Nice.
So maybe, but they also might just rely on those kind of external things that take advantage of Unreal. So I don't know.
Okay. We do have a question from YouTube. Modern Scholar asks, how does one add assets or create them for Unreal?
Pretty much all of it is made in a 3D package, such as 3ds Max, Maya, Blender. You'll make the models there. There's some other packages you could use too, but those are the primary ones. You would do it there and then import. It's a pretty simple import process now. It's all been refined pretty easily, pretty nicely over the past several years. Used to be a huge pain to import assets. And now they even have working on a plugin called LiveLink. So basically it will allow Unreal and your 3D package to share a 3D object.
Oh.
So it'll basically use the same memory in your system memory. It's the same object as in that memory. So it's a direct. If you edit one, it automatically edits in the other one, so it's just constantly updating.
Nice.
Which also saves overhead on your system. Instead of if you have a model that's 6 gigabytes or something, you don't have to load it twice into RAM.
Oh.
It just sits in there one time.
Yeah.
So yeah, 3D package, then just import it.
Right on. Just off as an aside, is Rhino 3D still a thing?
It's still out there, I think.
Okay, I remember that was kind of the big one when I was like a freshman in high school or something. They taught us that in I did a drafting class, and that was part of it.
Yeah. And Daz was another one that was like for characters or poser.
Okay.
That still kind of exists. It's not like it used to be anymore. It's just basically to generate background characters for architecture programs. But yeah, I think Rhino still exists. It's just
I remember it being like the more popular one, but Maya was like an afterthought at the time, or it seemed that way.
I think Rhino came in at like really cheap. Whereas at the time, Maya was like thousands of dollars, what still is, but like tens of thousands of dollars back then.
Yeah.
And Rhino was like a couple $100 or something. That's how a lot of them went. But then Maya's become cheaper, more accessible, and Unity is taken over, or Blender is taken over a lot of the lower end modeling packages.
Yeah. Actually, that's an interesting. You mentioned Unity. Is that anything that we like? Where does that stand in this at all? Is that?
I've been keeping my eye on them. They are pretty big in game dev, which is an area that we want to try to look into more. They don't have quite the reach into other industries other than game dev. So it just has less versatility for our customers. I just watched a real-time rendering or ray trace rendering workshop that NVIDIA hosted for Unity.
That was nice
to like go over some of that stuff. And it looks really good. It's doing some pretty impressive stuff, but it is still just a little bit behind Unreal. I don't know anyone that's using it in virtual production. Even architecture visualization, it's not really that big of a thing. But in game dev, especially indie games, all that kind of stuff, it's pretty popular.
Yeah.
I haven't seen any of the like plugins to be able to synchronize like LED walls or any of that kind of stuff in Unreal yet. So we want to. It's kind of on the radar. We're keeping an eye on it. We do have a Unity recommended system in our portfolio, but it's mainly just kind of maintaining it as like we know what a game developer needs as far as like code compiling takes multiple cores and all that kind of stuff. So kind of maybe eventually, not right now.
I guess so. We've just got maybe a minute or two left. I'm curious, as if say, and this is going to be pure game dev question, as a beginner, like say somebody like myself wants to get into. I want to make my own little goofy Flappy Bird or not something a little more complicated. I want to make a cool game. The hardware considerations. Where should I start?
If you're doing, especially if you want to do mobile. Your hardware considerations are actually pretty wide open. Like it doesn't take a lot to do a game. Like even if you want to do, say you want to do the next Among Us, like you want to do something like that, it doesn't take much.
Okay.
You're not going to need a lot of horsepower. Code compiling is going to be your biggest drawback.
Okay.
That's something you're not going to do too often. If you're doing it in Visual Studio, that kind of stuff, a lot of times it's kind of iterative. So like if you've built the code and you want to do some more, then you don't have to like recompile the entire thing.
Sure.
So it kind of helps you save some time. And then graphics, it just depends on how impressive you want the graphics to look. If you need to do a lot, but you can make some pretty great games without using crazy hardware. So yeah, I would highly recommend if anyone out there is interested in like dipping a toe, doing a little something. I actually have a blog post on our website that it was created at the beginning of the pandemic. Everyone's getting stuck at home, and it was a blog post about different game engines or different things you can do with kids to like get them introduced to coding and developing and all that kind of stuff. But it goes all the way from like really like 5-year-olds learning code all the way up to, you know, high schoolers or adults wanting to learn Unreal and getting a higher end game developing experience. But there's all kinds of free or cheap engines out there that you can get, like Game Maker or Unity, Unreal. I forget some of the other ones I had in the article. But yeah, there's a lot out there to get your feet wet into different types. And I would suggest doing some research. Like if you know you want to do a 2D side scroller, you can do that in Unity or Unreal. But there's also some other engines that might be a little bit easier.
Sure.
So yeah, just do some research. There's definitely options out there. It's the bar to enter into creating your own game is fairly low.
Yeah.
It's
I mean, there's been some pretty amazing things done by like solo devs. I mean, look at things like I think Firewatch was one person. Stardew Valley, I know for sure was one person. So yeah.
Phasmophobia is one guy.
Oh,
or
that's cool.
Guys. Yeah.
Wow.
I have a friend that makes games for. Well, I met him. He was a developer when I was at Xbox. I was the QA lead for his game, and we've become friends since then. And like he's made 5 or 6 games now that have been released on Xbox or PlayStation all by himself. Yeah, you can get in there.
Nice. Cool.
And he created his own engine, so he doesn't count. He's created.
He doesn't count. Still, that's pretty impressive too. So, but okay. Well, I guess that does bring us a little over our hour. So we'll wrap it up here, I suppose.
Right.
So thank you, Kelly. Is there any last little words of advice or anything you want to shout out or mention to the public at large or the people who might be listening in the future?
No words of advice. Stay happy out there. It's tough. But if you want to see more of game dev benchmarks, any of that kind of stuff, please reach out. I'm looking for any information. I'm reaching out to other communities as well. So if anyone out there wants to be like, hey, can you look at this? Can you investigate this aspect of game development? Please let me know and I'll add it to my list.
And I posted at least your handle on Twitter there in the chat for everybody. So and just in case anybody's just listening, it's at KW Shipman. Yeah. All right. So then I guess we'll say goodbye. Thank you, Kelly, for taking time out of your day and sharing all this with us. I'm excited to see the future of both game dev and in particular video production or virtual production rather. I feel like we're right on the cusp of some really, really cool things, and it's going to be mind blowing. So thank you very much. And I would like to thank the audience as well for joining us today for our Labs Open Office Hour. We do this sort of thing every Wednesday and Friday at 1 p.m. Pacific. Wednesdays, we bring in outside experts to talk about their workflow, tips, tricks, and advice for that sort of thing. And then Fridays, we bring in our experts to kind of give a rundown of anything new in our sort of fields of view, the whatever softwares they're experts in, the crossover there of the hardware and software, and also to answer questions from you guys. So be sure to mark your calendars for that. Wednesdays, Fridays, 1 p.m. Pacific, and we'll see you guys next time.
See y'all.